Hello everyone. In this video, we will discuss about detergents. Under this topic, we will discuss structure of detergent, its types, and its applications. Now let's start with the introduction of detergents. The word detergent is derived from the Latin adjective detergens, from the verb detergere, meaning to wipe or polish off. Detergent is a surfactant or a mixture of surfactants with cleansing properties when in dilute solutions. However, conventionally, detergent is used to mean synthetic cleaning compounds as opposed to soap, which is a salt of the natural fatty acid. Even though soap is also a detergent in the true sense, in domestic context, the term detergent refers to the household cleaning products such as laundry detergent or dish detergent, which are in fact complex mixtures of different compounds, not all of which are by themselves detergents. There are a large variety of detergent, a common family being the alkyl benzene sulfonate, which are soap-like compounds that are more soluble in hard water because the polar sulfonate of detergent is less likely than the polar carboxylate of soap to bind to calcium and other ions found in the hard water. Now the question is, what is detergency? The detergency is the ability to remove unwanted substances, termed soils, from a substrate, for example, clothing. Now let's discuss the structure of detergent. Detergents are a group of compounds with an amphipathic structure like surfactants, where each molecule has a hydrophilic polar head and a long hydrophobic nonpolar tail. The hydrophobic portion of these molecules may be straight or branched chain hydrocarbons, or each may have a steroid structure. The hydrophilic portion is more varied. They may be ionic or non-ionic and can range from a simple or a relatively elaborated structure. Now let's come to the cleansing action of the detergent. Detergents are surfactants since they can decrease the surface tension of water. Their dual nature facilitate the mixture of hydrophobic compounds like oil and grease with water because air is not hydrophilic. Detergents are also foaming agents to varying degrees. Detergent molecule aggregate to form micelles, which makes them soluble in water. The hydrophobic group of the detergent is the main driving force of micelle formation. Its aggregation forms the hydrophobic core of the micelles. The micelle can remove grease, protein, or soiling particles. The concentration at which micelles start to form is the critical micelle concentration, CMC, and the temperature at which the micelles further aggregate to separate the solution into two phases is the cloud point when the solution becomes cloudy and detergency is optimal. Detergent work better in an alkaline pH. The properties of detergents are dependent on the molecular structure of the monomer. The ability to form may be determined by the head group. For example, anionic surfactants are high foaming, while non-ionic surfactants may be non-foaming or low foaming. Now let's come to the type of detergents. Depending on the charge of the head group of the molecules, detergents can be classified into 4 types. The first type is of anionic detergents. Typical anionic detergents are alkyl benzene sulfonates. The alkyl benzene portion of these anions is lipophilic and the sulfonate is hydrophilic. These can be further divided into 2 types. Number 1, with branched alkyl groups, and number 2, with linear alkyl groups. The former were largely phased out in economically advanced societies because they are poorly biodegradable. Anionic detergent is the most common form of detergent, and an estimated 6 billion kilograms of anionic detergents are produced annually for the domestic market. Bile acids such as deoxycholic acid (DOC) are anionic detergents produced by the liver to aid in digestion and absorption of fats and oils. The next style is of cationic detergents. Cationic detergents are similar to anionic ones, but quaternary ammonium replaces the hydrophilic anionic sulfonate groups. The ammonium sulfate center is positively charged. Cationic surfactants generally have poor degeneracy. The third type is of non-ionic detergents. Non-ionic detergents are characterized by their uncharged hydrophilic head groups. Typical non-ionic detergents are based on polyoxyethylene or a glycoside. Common examples of the former include Twin, Triton, and the Briss series. These materials are also known as ethoxylates or PE glylates, PE gylates and their metabolites. Nonphenols. Glycosides have a sugar as their uncharged hydrophilic head group. Examples include octyl thioglucosides and maltosides. HEGA and MEGA series detergents are similar, possessing a sugar alcohol as head group. Amphoteric or zwitter ionic detergents have zwitter ions within a particular pH range and possess a net zero charge arising from the presence of equal number of +1 and -1 charged chemical groups. Examples include CHAPS. Now let's come to the applications of detergents. They are used in household cleanings, as fuel additives, and as biological reagents. Let's start with household cleaning. One of the largest applications of detergents is for household and shop cleaning, including dishwashing and washing laundries. These detergents are commonly available as powders or concentrated solutions, and the formulation of these detergents are often complex mixture of a variety of chemicals aside from surfactants, reflecting the diverse demand of the application and the highly competitive consumer market. These detergents may contain the following components. They may contain surfactants, foam regulators, builders, bleaches, bleach activators, enzymes, dyes, fragrances, and other additives. The second application is as fuel additives. Both carburetors and fuel injector components of internal combustion engines benefits from detergents in the fuels to prevent fouling. Concentrations are about 300 parts per million. Typical detergents are long-chain amines and amides such as polyisobutylamine and polyisobutylamide or succinimide. Detergents are also used as biological reagents. Reagent-grade detergents are employed for the isolation and purification of internal membrane proteins found in biological cells. Solubilization of cell membrane bilayers requires a detergent that can enter the inner membrane monolayer. Advancements in the purity and sophistications of detergents have facilitated structural and biophysical characterization of important membrane proteins such as ion channels. Also, the disrupt membrane by binding lipopolysaccharide uh, transporters, signaling receptors, and photosystem second. Now let's come to the laundry detergents. Laundry detergent is a type of detergent or cleaning agent used for cleaning dirty laundry or clothes. Laundry detergent is manufactured in powder in powder, we generally known as washing powder, and liquid form. Washing laundry involves removing mixed soils from the fiber surface. From a chemical viewpoint, soil can be grouped into water-soluble soils such as sugar, inorganic salt, urea, and perspirations. Soil particulates, soils such as rust metal oxide soot known as carbon black, carbonates, silicates, and humus. Hydrophobic soils such as animal fats, vegetable oils, sebum, mineral oil, and grease. Proteins such as blood, egg, milk, and keratin from the skin. These require enzymes, heat, or equally to hydrolyze and denature them into smaller parts before they can be removed by the surfactants. Bleachable stains such as wine, coffee, tea, fruit juice, and vegetable stains. Bleaching is an oxidation reaction which turns the colored substance into a colorless one, which either stays on the fabric or maybe arrives to wash out. Soil difficult to remove are pigments and dyes, fats, resins, tar waxes, and denatured proteins. Now let's come to the components of detergents. Detergent contains many components. The laundry detergent may contain builders, 50% by weight approximately, surfactants 50%, bleach 7%, enzyme 2%, soil anti-deposition agents, foam regulators, corrosion inhibitors, optical brighteners, dye transfer inhibitors, fragrances, dyes, filters, and formulation aids. Let's start with builders. Builders, also called chelating or sequestering agents, are water softeners. Most domestic water supplies contain some dissolved minerals, especially in hard water areas. The metal cation present in these dissolved minerals, particularly calcium and magnesium ions, can react with surfactant to form soap scum, which is much less effective for cleaning and can precipitate onto both fabric and washing machine components. Builders remove mineral ion responsible for hard water through precipitation, chelation, or ion exchange. In addition, they help remove soils by dispersion. The earliest builder was sodium carbonate, which is also known as washing soda, and sodium silicate, which is called water glass. In the 1930s, phosphates, for example, sodium phosphates, and polyphosphates, for example, sodium hexametaphosphate, were introduced. Continuing with the introduction of phosphonates. While these phosphorus-based agents are generally non-toxic, they are now known to cause nutrition pollution, which can have serious environmental consequences. As such, they have been banned in many countries, leading to the development of phosphorus-free agents such as polycarboxylates, citrates, silicates, gluconic acids, and polyacrylic acids, or ion exchange agents like zeolite. Alkali builders may also enhance performances by changing the pH of the wash. Hydrophilic fibers like cotton will naturally have a negative surface charge in water, whereas synthetic fibers are comparatively neutral. In the negative charge is further increased by the absorption of anionic surfactants. With increasing pH, soil and fibers become more negatively charged, resulting in increased mutual repulsion. The optimum pH range for the good detergency is 9 to 10.5. Alkalis may also enhance wash performance via the saponification of fats. Builders and surfactant work synergistically to achieve soil removal, and the washing effect of the builder may exceed that of surfactant. With hydrophilic fibers like cotton, wool, polyamides, and polyacrylonitrile, sodium triphosphates remove soil more effectively than a surfactant alone. It is expected that when washing hydrophobic fibers like polyesters and polyolefins, the effectiveness of the surfactant surpasses that of the builder. However, this is not the case. Now, the next component is surfactant. Surfactants are responsible for most of the cleaning performance in laundry detergent. They provide this by absorption and emulsification of soil into the water, and also by reducing the water's surface tension to improve wetting. Laundry detergents contain mostly anionic and non-ionic surfactants. Cationic surfactants are normally incompatible with anionic detergents and have poor cleaning efficiency. They are employed only for certain special effects as fabric softeners, anti-static agents, and biocides. Zeta ionic surfactants are rarely employed in laundry detergents, mainly for cost reasons. Most detergents use a combination of various surfactants to balance their performance. Until the 1950s, soap was the predominant surfactant in laundry detergents. By the end of 1950s, so-called synthetic detergents, synthents like branched alkyl benzene sulfonates had largely replaced soap in developed countries. Due to their poor biodegradability, these branched alkyl benzene sulfonates were replaced with linear alkyl benzene sulfonates (LAS) in the mid 1960s. Since the 1980s, alkyl sulfates such as STS have found increasing application at the expense of LAS. Since the 1970s, non-ionic surfactants like alcohol, ethoxylates have acquired a higher share in laundry detergents. In the 1990s, glucamides appeared as co-surfactants, and alkyl polyglycosides have been used in specialty detergents for fine fabrics. The next component is bleach. Despite the name, modern laundry bleaches do not include a household bleach, which is sodium hypochlorite. Laundry bleaches are typically stable adducts of hydrogen peroxide, such as sodium perborate and sodium percarbonate. These are inactive as solids, but will release hydrogen peroxide upon exposure to water. The main targets of bleaches are oxidizable organic stains, which are usually of vegetable origin, for example, chlorophyll, anthocyanin dyes, uh, tannins, humic acids, and carotenoid pigments. Hydrogen peroxide is insufficiently active as bleach at temperature below 60 degrees centigrade, which traditionally made hot washes the norm. The development of bleach activator in the 1970s and 1980s allowed for lower washing temperatures to be effective. These compounds, such as tetraacetyl diamine (TAED), react with hydrogen peroxide to produce peracetic acid, which is even more effectively bleach, particularly at lower temperatures. Next component are enzymes. The use of enzymes for laundry was introduced in 1913 by Otto Rohm. The first preparation was um, a pancreatic extract obtained from slaughtered animals, which was unstable against alkali and bleach. Only in the latter part of the century, with the availability of thermally robust bacterial enzymes, did this technology become mainstream. Enzymes are required to degrade stubborn strains composed of proteins, for example, milk, cocoa, blood, egg yolk, and grass. Fats, for example, chocolate, fats, oils. Starch, for example, flour and potato stains, and cellulose, uh, damaged cotton fibrils, vegetables, and fruit stains. Each type of stain requires a different type of enzyme. For example, protease for proteins, lipases for grease, alpha amylases for carbohydrates, and cellulases for cellulose. Many other ingredients are added depending on the expected circumstances of use. Such additives modify the foaming properties of the product by either stabilizing or counteracting foam. Other ingredients increase or decrease the viscosity of the solution or solubilize other ingredients. Corrosion inhibitors uh, counteract damaged washing equipment. Dye transfer inhibitors prevent dyes from one article from coloring other items. These are generally polar water-soluble polymers such as polyvinyl pyrrolidone, to which the dyes preferentially bind. Anti-redeposition agents such as carboxymethyl cellulose are used to prevent fine soil particles from reattaching to the product being cleaned. Commercial or industrial laundries may make use of a laundry shore during the final rinse cycle to neutralize any remaining aqueous surfactants and remove acid-sensitive stains. A number of ingredients affect aesthetic properties of the item to be cleaned or the detergent itself before or during use. These agents include optical brighteners, fabric softeners, and colorants. A variety of perfumes are also components of modern detergents, provided that they are compatible with the other components and do not affect the color of the cleaned items. The perfumes are typically a mixture of many compounds. Common classes include terpene alcohols, uh, such as citronellol, geraniol, linalool, nerol, and their esters, such as linalool acetate, aromatic haldehydes, for example, helionyl hexyl cinnamaldehyde, lilial, and synthetic musk, for example, galaxolide. This is all about the detergents and their components. In our next video, we will discuss about another topic. Thank you.